Okay, hello everyone. Today we are talking about chapter 10.2. There is the Pythagoras theorem and its proofs. And some of you may have already heard about the Pythagoras theorem. And in Chinese, it's called 不是定理.不是定理. In fact, it's a very famous theorem in mathematics. So what does it tells? I'm going to show you. And you can see that if there is a triangle, and if there is the right angle here, that means if there is a right angle triangle, then we can have the Pythagoras theorem. For example, I let it the length become AB or C, okay? A, B, and C. And for the C, it is a special line that is called hypotenuse. Hypotenuse. You have already learned in Form 1 that is called 斜邊. 斜邊. And it is the length opposite to the right angle, right? Opposite to the right angle. Also, it is the longest length in the triangle, the longest one. So what does the Pythagoras theorem tell? I'm going to tell you. The Pythagoras theorem tells that the c square, that is the longest length, the square of the longest length, will be equal to the sum of the square of the other two lengths. That is a square plus b square. Understand? The longest one, c square, will be the other two, the a square plus b square. Okay, that is the Pythagoras theorem. And remember, in this chapter, we should also write down the reason for using the theorem. The Pythagoras theorem is, in short, we can say Pyth dot, and then theorem Theorem. Okay, so we remember this reason again for the Pythagoras theorem. So I'm going to show you one example. For example, if there is a triangle, right angle triangle. The right angle is very important to use the theorem. For example, this one is 4, this one is 3, this one is x. If we want to use the x, again, we can use the Pythagoras theorem, okay? The x will be the longest one, that's the hypotenuse, so we know that x squared will be equal to the sum of the square of another two lengths. That is 4 squared plus 3 squared. Of course, we should write down the reason, Pythagoras theorem. Okay, and then we can use what we have learned in chapter 10.1, that is this one 16.9, 25. And then we want to take out the square, we can put the square root, right? But this time we do not need this side, positive or negative side. We do not need this one. Why? Because we know that the x is the length, right? The length of this hypotenuse. So in length we do not have negative values, so we can just write down square root 25. That is the positive one. We do not need to find the negative one. So if you use the calculator, or you may calculate by yourself, you know that the answer should be positive 5. 5 squared is equal to 25, right? So we can get the answer. So that's how Pythagoras can help me to find any length of the right angle triangle. Okay, so some of you may ask you, oh, is this theorem true? So I want to tell you how this theorem, how can we prove the theorem. In fact, in the world, there are many different kinds of proof about this theorem because it's so famous. If you are interested, you may search it in Google or YouTube. So I'm going to show you one of the proofs of this theorem. Okay, show you one of the proof only. Okay, so first of all, for example, I use the same triangle. Okay, that is A, B, and C. Okay, and for this triangle, we know that when we want to consider the area, we can use the 1/2 times the base, this one, and then times the height, this one, right? And then we simplify, we can get AB/2, right? Okay. Also, before we prove, I also tell you some properties. For this angle is theta, right? I let it theta. And then for another one, this one, for this angle, we know that in this triangle, this angle, and this right angle, the sum of these three angles should be 180 degrees, right? That is the right angle plus the green one, and then plus the purple one will be equal to 180 degree, right? This one is angle sum of triangle, right? So you may because we let it this one is theta, this one is 90 degree. So you simplify, you can get the purple one will be 90 degree minus the theta. Okay, so this one is 90 degree minus theta. Okay, then okay, you can you know these two, then we can prove it to you now. So you should remember this three angle, add them together will be 180 degree, and that's enough. Okay, and also for this triangle, the area is AB over 2. Okay, then now I construct a figure like this. I construct a big triangle. Okay, and then inside the triangle I make 4 lines. Sorry, I mark it again. Okay, and in fact, this 4 triangle, in fact, I make it to become this triangle. That means, what does it mean? That is, for example, this one, right triangle, and then I put this line is A, this line is B. For another triangle, again, I put this one is A. The shorter one become B. And then similarly, this one is A, this one B. This one is A, this one B. Okay, understand what I mean? I put the same triangle, I copy 4 times, and then we got 1, 2, 3, and 4, right? 1, 2, 3, and 4. 4 triangle, right? The same triangle, congruent triangles. Okay, and then we can make such a big square here. Big square, right? You can see this one, oh, A plus B, right? This one also A plus B. And then we have 4 right angle here, so it must be a square, right? A square. So inside the square, we can see the marked line. This one should be C, C, and C, and C, right? All of them are C. And I tell you, inside this one, in fact, is also square. All of them are right angle. Why? Because again, I mark all the angle. For example, for this one should be the green one, right? And then for this one should be purple one, right? And we know that for this one should be a 180 degree, because this one is adjacent angles on straight lines. So we know that this angle plus this angle plus this angle should be 180 degree. From what we have told you before, a green angle plus a purple angle plus a 90 degree will become 180 degree. So this one must be a 90 degree. Understand? So we know that this one is a square. Similarly, all of them, this one green, this one green, this one green. And then for another angle, this one purple, this one purple, this one purple. And we know that all of them are in this combination: green, 90 degree, purple, green, 90 degree, purple, green 90-degree purple, green 90-degree purple. Okay, so you can see inside the figure is also a square with the length c, right? Okay, we can construct such a figure. So now I'm going to prove the Pythagoras theorem, this one, by consider the area of the figure. First of all, if I consider the area of inside the square, we have such a square C, right? C. Okay. We know that for square, easy, C square, right? But in fact, for this square, the area we can just like right square, this one, sorry, the whole square, right? And then we minus this part, this part, and this part, right? When we minus these four parts, then we have remain the square of the C, right? So we are going to refine about what is the area of this part. So for the largest part is the square. The length is a plus b, so we know that the area will be a plus b whole square, right? For the second part, minus, we know that it consists of four triangles, so we have 4 times the area of the triangle, and we already proved that the area is AB over 2, so AB over 2. Okay, and then we can simplify this one by using this one is identity, a squared plus 2ab plus b squared. This one is 4 times AB over 2, that is 2ab, right? And you can see these two can be cancelled, right? Positive, negative. So we can see in this length we have this one is a squared plus b squared, right? A squared plus b squared, and it's equal to the c squared here, right? We are talking about the same area, so we can see we have already put the theorem that is c squared is equal to a squared plus b squared. So that is one of the proofs of the Pythagoras theorem. If you are interested, you may find more proofs by Google the Pythagoras theorem and its proofs. And I will talk about how we can do the exercise by writing down the step to find the unknowns by using the Pythagoras theorem. I will show you in the next video. Okay.